Hey there everyone, welcome to the series Automate the Boring Stuff in Ansys Mechanical. This is part 2 of our previous video, Engineering Data and Materials. I realized that I missed some of the important things in my previous video, so I thought of covering in this new video. So let me just go to command window once again. And if you see, I am already in engineering data and I do not have any material. So first thing I wish to show you that how to import an existing material. Then we will create a material and we will see some of the properties. Last time when I was trying to create elasticity, it was giving some error. Then I realized that I am actually missing one of the argument, or in few cases there are two arguments. And then we will export the material as an XML file to some folder, and we will try to import the same material from the exported folder. So let's do one thing. Let's get to the engineering data quickly. So it will be sys is equal to get system and name is sys, and then from here engineering data is equal to sys dot get container. It's container, and then component name is equal to engineering data. And then once we have that engineering data, so if I type ed, we have engineering data here. So let's say I want to import a material which is already existing. So first thing is you need to see the data source. Okay, so here we have some fluid material, then we have some uh, general materials. So let me import anyone, for example a concrete, from general material. So what I have to do is, since I am importing into my engineering data itself, so I have to access the engineering data. Then from here I will just type import material. Remember, there are two things: import and import material. Import material is for the material which is already existing in engineering data sources, and import is for an external XML file. I mean the material which is stored in an XML file. So here in import material, the name will be concrete. So concrete, and remember we have to give the source name. So as you see, these are all the data sources here. Here the data source is general material.xml. So this is also stored in an XML file. It is within the Ansys installation directory. So I will just type general materials dot xml. I wanted to show you something. See, whatever you are seeing is the display text, right? We used to change this display name. So it is general space material, but actually the file name is something like this: general underscore materials dot xml. So you have to type underscore here and then press enter. You will see now it has assigned the material to some variable which we have not given. So it is just returning that engineering data material. And if I go back engineering data, you will see concrete has been assigned. Similarly, let me just go to fluid materials, and from fluid I will try to access uh, under fluid material. Let me see what is available. Let us do maybe acetone. So let's go back to engineering data, and here I will just type acetone. So here I have acetone, and you will see acetone has been assigned from fluid materials XML. So this is something of this is something we are importing which is already existing. So let's just create a new material, and let's see what and all things we were missing in our previous video. So here let me just delete it and keep it clean from here. So as you remember, let me create my mat as material. So my mat is equal to ed dot create material, and name is equal to my mat. So now my material is created. We have already seen how to create a density, like my mat dot create property name is equal to density. Now density has been assigned, you can see here, but the problem was coming when we were doing for elasticity. So few things that I wanted to cover up here. There are few arguments, or let's say there are few parameters for the function create property. So here density is fine, it is pretty straightforward, but this is not the case for others. So there are three things you need to remember. One is name, a definition, and behavior. So when I say name, it is density, temperature, coordinate x, like this one, density. What else we have? We have something like uniaxial test data, then new Hookean hyperelastic, gent, and what else? And then uniaxial plastic strain test data. This is also just a name, but the definition and behavior comes for this multiple names. For example, this one. So coefficient, you see, this is a three-part name. Okay. So coefficient of thermal expansion, this is a name. Isotropic is a behavior, and second is definition. Similarly, this one, coefficient of thermal expansion is a name. Isotropic is a behavior. Definition is instantaneous. Now, similarly, elasticity, you must have seen the previous video. We were facing some issues. So here, name was elasticity. We were passing the name correctly, but we actually missed the behavior. So remember, isotropic, orthotropic, and isotropic, these are behavior. Rest all the things are name. There is one more behavior. Let me just see which one it is. Yeah, here it is. This one. So remember, isotropic hardening is a name. Bilinear is a definition. Multilinear is a definition. Non-linear is a definition. Isotropic hardening is a name. But power law is a behavior. So power law, isotropic, orthotropic, and isotropic, these are behaviors. Rest other things are name. Second, and non-linear, bilinear, these are all definition. So these things I wanted to cover in this video more specifically. So let me create everything slowly and then I will show you what it is. So first thing is I will rerun it. I will not assign any variable or values now. We have already seen in the past how to send a tabular data, how to send single variable data, all those things. So here I will just show you how to create a property with multiple parameters. So name, here it is, coefficient of thermal expansion, and then we missed this in previously. So next is behavior. Behavior is equal to, here we have isotropic, and then we have definition. Definition is equal to second. So if you see that, you will see isotropic second, the coefficient of thermal expansion is being created. Similarly, let's go to the elasticity. So in elasticity, I don't have definition. I will delete the definition parameter. Here I have isotropic, that is fine. And in name, I will just send elasticity. In our previous video, we were getting some error because we were sending only the name. We were missing the behavior part. So if I do that, now it will not show any error. From here, you can just go to property uh, like Young's modulus. Then you can access the variable Young's modulus and also the temperature. You can send single values or tabular values that we have already covered. And then we have uniaxial test data. So this is I believe this is a single line. Let me just check. Let me rerun it to check it. So here I have uniaxial test data. Yes, it is coming correctly, so there is no issues. And then similarly, new Hookean, this is also a name, that is fine. This complete is a name, that is also fine. Now comes isotropic hardening. Here there is something different. So we have isotropic hardening, and since bilinear, multilinear, non-linear, this comes under definition. So it's not a behavior. So definition is equal to, we have, let's make it multilinear, and you will see multilinear isotropic hardening is added. Now if I want to add this power law isotropic hardening non-linear, so all I have to do is, this will be non-linear, isotropic hardening is fine, and then behavior. So four things. One was isotropic, anisotropic, orthotropic, and this power law. This comes under behavior. So I will just show you how to remember all this. So you don't have to remember everything. There is a way to do that. So you will see nonlinear isotropic hardening is added. Strain hardening, this is a complete name. Strain hardening is a complete name. SN curve is also a complete name, but SN curve linear comes under definition we have already seen in the previously. So here you have to enter SN curve as name and linear as definition. And some other things, for example, gasket model, this is a complete name. Shear data, viscoelastic, these are complete name. Then what else, like fracture, linear fracture criteria, this is a complete name. So here we don't have this these things, like we don't have name and sorry, behavior and definition here. So that is all we had for this, and few more things. Yeah, I didn't show you that suppressed state as well. So my mat is like, if you want to see whether this material is suppressed or not, you just have to type uh, this is a function, this is a method actually. So my method is suppressed, it's telling false. So if you want to make it true, you have to type set suppression, and then you have to pass it true. So you will see this checkbox is actually unticked now. So if I make it true, you will see it has suppressed, and if you type is suppressed, then you will get it true. And if you go back to if you unsuppress, if you want to unsuppress it, just type false, it will be unsuppressed, and then we can duplicate it. So it will be my mat dot duplicate. I think we are missing something, are missing or not target container. So I think we have to type ed. Yeah, so you can see the error what it was showing. It is missing an argument which is target container, so where you want to create it. So my container was ed, so if I do that, it will create this. And then similarly, so this is already duplicated, so let me delete the original, which is my mat dot delete. And you will see in the back, my mat is deleted, my mat 2 is there. My mat 2 is not assigned to anything, so I will just have to assign it to some variable to work around. So let me just clear it and open new one. Okay, so let me access my mat. So my mat 2 is equal to ed dot get material, and name is my mat 2, my mat 2. So we have my mat 2 here. So next thing that I want to show is I want to export it. So to export, there is an engineering data which is reserved. It's not the ed that we have assigned, it will be eng data. Remember the eng, remember the case, e is capital and d is capital. And then from here I have to write material, and then here material list. So how many materials you want to send. For example, it can be single my mat 2, or there can be multiple materials as well. You can export multiple materials into a single XML file, similar to what we have seen in the general materials. So this file is actually a single file, but you have multiple materials within the single XML file. So I can send it this. Then I have to send file path. You don't have to remember all this, I am telling again and again. I will just copy a path from my existing folder, and then this will be my path. Here it will be my mat 2. And then we have format. This XML format, you have to explicitly mention it here, mat ml31. Again, no need to remember all this. I will just show you how to record this, and then it will be easy for you. Now unit system, under what unit system you want to export this. So I will let us make a SI, or it can be in system as well. It will be bin standard, and then that's it. If I do that, I think, yeah. So as you remember, I have some escape characters. So here you just make it r string, so it will escape the escape characters. And if I show you what is exactly present in the folder, uh, so it will be import os dot list directory, and it will be, so this is what we had. This is a folder, and if I show you that folder, some illegal characters are there. I'll just type r. Yeah, so you will see my mat2.xml is exported, right? So then Now if I rerun that code again, for example, I have already exported it and I want to, let me open a new window. Okay, so if I try to do that again, it will throw me an error telling that this already exists. So to avoid such kind of errors, you can just type replace material. Like whenever you try to replace existing material, it gives you a pop-up, right? To avoid that kind of errors, since we are doing automation, you can just type true and it will replace that existing material. And then let me import the material which we just exported, which is this one, mymat2.xml. So what you have to do is here you have to type ed. This is our container, but this ed was our workbench engineering data. I mean general engineering data. This one, this engineering data is not tied to any container or any analysis system, right? So that's why that eng data is there. But ed is something, this A2 engineering data where we are trying to import. So this will be ed dot import, and then you just have to pass in the path. That's it. No, not this one. So once we do that, multiple parameters failed, so I think I'm missing some. uh, so this will not be imported because this is already existing. It has to be unique, so I'll just type this. Okay, so actually that material was not having any properties, right? So what I will do is uh, I will just uh, I will just export air there, and then what I will do is I will export air as some like let me assign my mat as air ed dot get material name is equal to air, and here my mat is there. Now I will just rerun this code, and this one is my mat, and here air dot xml replace to is exported. If I delete this and then try to rerun this code, import, then hopefully I should not get any error. Okay, it's giving me error. It's strange. I think I'm missing something. I think there is some issue. I don't know which one is giving me this issue. Let me just change this forward slash to backward slash. It should work. Multiple parameter details. MyMat2. Oh, it's not MyMat2. It's uh, this air.xml, right? We just exported to air, and then you will see air is imported. My bad. I was just importing the old name. This is for importing, and yeah, there is one more thing, like we added this unit system, right? To get the unit system, uh, what you can do is just open one more command window, clean. Here you can just type get unit system names. So you will see we have done bin. You have multiple unit system. Anything you want you can export to XML file. And I think I've covered most of the things. Yeah, one more important thing, how to know which one to use. So there is a simple trick. So what you can do is, suppose I have not done anything. Okay, it's blank. So I will just go to file, scripting, record journal. This will start recording. I will just type test record and then save it. Here what I will do, I will add a material. I will name is record material, record mat. Then I will add, let's say, density, then isotropic elasticity, and then I will give some random values, 22, 22.2. Then I will go file and then export. This is record mat, save it. Once I have done everything, I will go to scripting and stop the journaling. So this recording is completed. And if I open that recording file, I will just show you. Wait just a minute. Test record, and and this is how it looks like. So these things you have to decode. You have to edit based on your own requirement. So what it did is this is the same engineering data which we were assigning to ed dot create material record mat. Then we created a property density, then elasticity, behavior was isotropic. This is what I was missing. This is how I came to know that I'm missing something. And then these qualifiers are not required. Then we have set data where we entered 22 kg meter cube for density. Temperature we have not set. Similarly, Young's model index is also not required, but if you are assigning it correctly, then this is not required. And then Poisson's ratio, and then exporting. So it is ENG data. It's not engineering data or ED. It is ENG data. And then write material. You have to give path, format, unit system, replace material to avoid such errors. And this is how I learn things, especially for Workbench. You can also do things. You don't have to remember everything. So once you do this, it will be pretty straightforward. So that's all for today, guys. See you soon in next video.